Hi, today we're talking about CCM8, Unit 5, Lesson 3, solving one- and two-step equations. Some definitions for you. The solution is the value of the variable that makes the equation true. That's what we're looking for, the solution. Inverse operations, operations that undo each other. So addition and subtraction undo each other. Multiplication and division undo each other. An equation is a mathematical sentence with an equal sign. The golden rule of solving equations: whatever you do to one side of the equal sign, you must do to the other side of the equal sign. So we're going to solve our problems today, and then we're going to check our answers. So when I start here with number 1, x plus 10 equals 15. Now I know we could all probably do mental math and try to figure out the answer, but like all problems in math, we start with easy problems and we move to the more difficult problems. So if you get your fundamentals set, then you'll be good to go when it comes to the more difficult problems. So I'm going to use a golden rule. I'm going to use inverse operations. I see here that I'm adding 10 to x, so the opposite of adding 10 is subtracting 10. What I do to one side, I must also do to the other. Positive 10 take away 10 is nothing, so they cancel out, and I'm left with x. 15 take away 10 is 5. So my solution is x equals 5. How do I know I'm right? Well, I plug it in. Wherever my x was in the original problem, I plug in 5. 5 plus 10, well, what is that? 5 plus 10 is 15, and that's what it should be. Check. I did the right thing. Number 2, x take away 13 equals 40. So I have my x here. That's what I want to know, that value. I want to know what that value stands for. And in the problem, they're subtracting 13 from x, so I do the opposite of that. I add 13 to both sides. Negative 13 plus 13 is 0, so I'm left with x. 40 plus 13 is 53. So 53 is my answer. I plug in 53 where x was in the original problem, and then I simplify. 53, take away 13 is 40, and that's what I needed it to be. This is a true statement, so 53 is my solution. This is not my solution over here. My solution was x equals 53. Another example, 6y equals 72. So what's happening to y? Multiplication. What undoes multiplication? Division. So I'm going to divide both sides by 6, because what you do to one side, you also have to do to the other side. So 6 divided by 6 is 1. That's what I want. I want 1y. 72 divided by 6 is 12. So y equals 12 is my solution. I'm going to plug my solution back into the original problem and check to see if that's correct. So I had 6 times y. I said y was 12. So 6 times 12, that is 72, and that's what I needed it to be. One last example of these one-step equations. I have x divided by 2 equals 6. So I have to undo the divided by 2. What undoes division? Multiplication undoes division. So I'm going to multiply both sides by 2. This cancels out, so I've just got x by itself. 6 times 2 is 12, so x equals 12. I need to check my answer, so I plug in 12 for x in the original problem. 12 divided by 2 is 6, and that is a true statement. Now we're going to move on to some two-step equations. So for my two-step equations, I have step 1 is to undo any addition or subtraction. Do that first. Step 2, undo multiplication or division to get the variable by itself. There is an exception to this rule, of course, which we'll see in example 5. All right, so here we go. Solve. 2x plus 10 equals 16. My first step is to undo any addition or subtraction. So I need to undo that addition by subtracting 10 from both sides. That cancels out. I bring my 2x down, and then I simplify this. 16 minus 10 is 6. Now I'm left with 2x equals 6. So I undo the multiplication by doing division. What I do to one side, I must also do to the other. 2 divided by 2 is 1. So x equals 3, because 6 divided by 2 is 3. I go through and I check my work. I insert 3 where x was in the original problem. So x was being multiplied by 2. So in this case, when I rewrite my work to check it, I do 2 times 3 plus 10 equals 16. When I go through to check my work, I'm going to be using order of operations. So I'm going to multiply first. 2 times 3 is 6. Then add. 6 times 10, 16. So that's what I needed it to be. I'm on the right track. Number 2, 4x minus 13 equals 3. I undo the addition or subtraction first. So what's happening is they're subtracting 13. I need to undo that by adding 13. I add 13 to both sides because what you do to one side, you also do to the other. 13 plus 3 is 16. This canceled out. I'm left with 4x equals 16. I divide both sides by 4, and then I come to find out that x equals 4. So I plug that back in where x was in the original problem, and then I solve this using order of operations. 4 times 4 is 16. 16 take away 3. The 16 take away 13 is 30. So my answer checks out. All right, we're going to try these 3 together. So get your pencil ready. Here's our original problem. Negative 2x plus 12 equals 24. So the first thing I do is undo the addition or subtraction. Sometimes I draw a line underneath so that I know that's one step and I need to bring down my work. So plus 12 and minus 12 cancel out, but I still need to bring down what I didn't use. 24 take away 12 is 12. And then my last step is divide both sides by negative 2, so that I'll get x by itself. 12 divided by negative 2 is negative 6. And that's my solution. So to check my work, I'll plug in negative 6 where x was in the original problem and solve using order of operations this time. Negative 2 times negative 6 is positive 12. Bring down everything I didn't use. Ooh. And make sure you write it correctly. 12 plus 12 is 24. And that is a true statement. All right, here we go. X over 2 plus 12 equals 18. Now I said x over 2. That's the same as x divided by 2. So I still am going to undo my addition or subtraction first. Bring down what I didn't use. 18 take away 12 is 6. Multiply both sides by 2 because that is the inverse operation. In this case, x will equal 12. Remember, this is my solution. I'm just going to check my solution over here to make sure I did the right thing. So I insert my solution where x was in the original problem. 12 divided by 2 is 6. Bring down everything else. And 6 plus 12 is 18. So my answer checks out. Okay, here's the exception to the rule. So in problem 4 and problem 5, I have similar things going on. I've got division, I've got addition or subtraction, but the location of the numbers, letters, and symbols matters. Because what this is showing is it's showing, hey, this difference is being divided by 3. That entire difference is being divided by 3. So I can't remove any part of that difference until I remove the denominator of the problem. So I need to remove the denominator of the problem by undoing it. How do you undo division? You multiply. So I'm going to multiply both sides by 3 here to get rid of that. And then that kind of unlocks this numerator of my problem. So I just bring it down, x was 4. And then 6 times 3, 18. And now I undo the subtraction to get x by itself. 18 plus 4 is 22. So that's what goes inside these parentheses here when I go to check my work. 22 take away 4. That's going to be 18. 18 divided by 3, well, that's 6. And that's what I needed it to be. So we're all done here. Hope you learned something.